afternoon to everyone. My name is Franco Zardini, and I'm going to present to you the fog pilot, which was developed by ArpaVeneto, the environmental agency of Veneto Region, the region of Venice in Italy. Just a brief overview. Why we decided to develop this pilot, how the methods we used, and the results, the products we created. That's a nice view of fog in Veneto Plain as seen from our center. Well, I can start by saying that fog is a fascinating phenomenon which inspired painters, and here are some paintings by Monet, and he was very interested in the effect of fog, and in the title of the paintings there is an explicit reference to fog. But fog inspired also poets, and this is a very short poem by Carl Sandburg, an American poet. I like very much the first two lines, "The fog comes on little cat feet." But on the other hand, fog can also be very dangerous. Here there is a picture of a rail accident due to fog between Verona and Bologna. And here some numbers about fog-related accidents and social costs for Veneto Region. They are annual estimates. 220 accidents, about 5 deaths, and 35 million euro of costs. Well, fog is a very frequent phenomenon in Po Valley, and it's very regular and can assume very different patterns. I'm now showing you some satellite picture of fog, just to orient yourself. Here there is Lake Garda, and here there is Venice. This is a widespread fog and low clouds over the entire Po Valley, and this is very localized fog in the central part of Veneto. Another widespread fog which covers only part of Veneto region, and another localized fog. So you can understand that it is very difficult, to forecast fog, but I want to stress the attention also on the fact that it is very difficult also to detect it, even unless you are just inside fog. Fog detectors are deployed mostly along highway stretches, and they give local information. In general, there isn't an aerial fog monitoring network. What said before represents the reason why we developed the fog pilot. The purpose was to create a system to monitor the presence of fog on an area, even in places where you have no direct measurements or report, and then to disseminate such information in real time to different users. The usefulness can be for accident risk reduction, for safer travel, better choice of route, and better traffic and traffic-related activities. And potential users are individual travelers, road network or traffic management companies, and also weather forecasters, because a good monitoring system is the basis for a good forecast. Well, now we can give a look to some technical aspects. There are different instruments to detect fog, each with its pros and cons. The first one is the visibility detectors, the visibilimeters, which give a direct measure of visibility at ground level with good reliability. In the framework of the project, we have installed a 10 visibilimeter network over Veneto Plain. The problem is that it's a point measure valid just for the place, for one place, and we cannot obviously put an instrument in every place. The other instrument is the meteorological station, which gives information on meteorological parameters, humidity, temperature, wind, and it's a common and widespread instrument. It gives ground level measurement, but still it's a point measurement, and it's indirect. So meteorological station give hints on favorable condition for fog, but there is no straightforward relation with fog or visibility. So we need heavy statistical processing. And at last, satellite. Satellite images can be processed to give information about cloud type. In the picture you can see with the orange color the area where we have low clouds or fog. And satellite is very important because it gives an area coverage with a good resolution. But the problem is that it's an indirect measure and from above. So very low clouds may be associated with fog, but we cannot say exactly what happens at ground level. And we are interested in what happens at ground level. And if there are medium or high clouds, we have no information. So we have seen different instruments, different kind of information. What are we going to do with them? Well, the key idea of the pilot is to put them together and to take profit of the advantages of each source and minimize the negative aspects. But how can we do that? The methodology is the following. First issue is the homogeneity. We have to extract from very different data sources a common information. We choose the probability of reduced visibility, which can then be compared. Then second issue is the reliability. We associate to each probability a local weight depending on the observation and an overall weight related to the quality of the data source. Then the spatial coverage, we calculate probabilities and weights for each grid point in which the target area is divided. And at last, the merging process. We calculate the overall probability as a weighted mean of the probabilities derived from the different sources. Just a slide to summarize the model flow. We have different data, satellite, visibilimeter, and meteorological station. We have to extract a probability map from each source. Then we have to attribute a weight to this probability field, and then we match them together with a weighted mean, and at last we have the final product. We can give a look at the final product, which consists in a fog probability map. That's to say, a merged probability of visibility less than a threshold. In this case, it is 500 meters. In the picture, you can see with different colors the different probability classes. Then the green square show the location of the visibilimeter, and these are the information about temperature, relative humidity, and visibility. You see that in the eastern part of Veneto region we have high probabilities. Here we have Venice, but 4 hours later we have enhanced probability also in the western part of Veneto region. So fog extended over the region. And it can be useful also to give a look at the single system components. And here you can see that the strongest signal comes from the visibilimeters. In this case, we have pure or no signal from the station data, and satellite pictures show a medium probability, and it helps to modulate the probability field from visibilimeters in the sense that it enhances the probability in the southwestern part and it reduces it in the northwestern part and at the borders. A last question, how to pass from probability to warnings? Well, we can associate an alert level to a probability threshold. A good choice could be a 30-40% threshold to give a fog warning. And this was derived from a probabilistic verification to maximize the economic value of the monitoring system, and it corresponds about to a 75% probability of detection and 10% probability of a false detection. To conclude, you can give a look at our experimental real-time products. That's the website address. In next month, unfortunately for you, but fortunately for we who live in Veneto region, fog is very rare. So we have inserted a fog case of this winter, just you can see something real. And that's the conclusions. Well, a probabilistic area monitoring system has been built using limited number of visibility detectors, satellite data, and meteorological station data. A probabilistic verification of the fog pilot shows pretty good performance with probability of detection of about 70-80% and a probability of false detection between 15%. Most value to define a product is brought by direct visibility measurements, whereas a satellite brings added value, especially in the spatial interpolation. And the fog pilot has the potential to give support for accident prevention and traffic management. That's all. Thank you for your attention, and you can enjoy another spectacular view taken from satellite of snow in Po Valley, and you can see also of fog in Po Valley, and you can see also snow in the Alpine region. Thank you very much.
Again, we have a question for one, time for one question. From FMI.
Thank you, Franco. You seem to translate your probabilistic information into a categorical warning.
Yeah.
Have you thought that you could also provide the probabilistic information per se for the users?
Yes, the information we have put on the website, and we gave the address to some users just to give a look at the products, are the probabilistic maps. And then if you want to give a warning, you have to take into consideration not only the strict probabilistic verification to maximize or minimize the probability of detection or false detection, but also the user needs. Depends on the need of the user. Some user can prefer a higher warning level and other one a lower one. Right.
Thank you. Okay, we must continue now, and now we move a little bit further north to the Netherlands.
There is one more question.
Okay.
Are you cooperating with the traffic management authorities to provide information to the end users?
We are a meteorological center, so we are perhaps our participation in the ROADIDEA project was one of the first experience we had with other traffic experts. In Veneto, we have a contact with Highway because we provide a service to them, but Highway have already their own visibility network, very dense, but only along the highway stretches, not over the entire region. And we had a meeting with potential user, the first user meeting, in which we 15 users participated from generally companies or public authorities who are involved in traffic management or in the maintenance of the regional network. And this was the first one. Then we distributed these products to them, and then we have to do another meeting to understand how they can use this product.
Oh, still one, yeah, okay. Yeah. Quick one.
Very quick. You focus on the fog which is created naturally.
Yeah.
In some cities like Beijing or California, smoke which is created by humans coming from out of car or industries is a very big problem when it comes to visibility. So to what extent your model can be applicable for smoke?
Well, I think that the strength of this pilot is its area coverage. So if you need something for a specific location, perhaps the best thing is to have some visibility detectors in that places. Another point I want to stress is that this is not a forecasting tool, it's a monitoring tool, and so in this case perhaps they can be interested in a condition favorable to also the stagnation of pollution, not only of smoke and so on. but this is more forecast. If you are interested in the monitoring, perhaps in a limited area, if you have a specific interest, it is better to have a direct measurement system.